Hi everyone, I'm Ceren. In this video, I'll walk through my solution for assignment 4, where we use the pandas library to perform data analysis and manipulation. In the first step, I loaded the data from a CSV file into a pandas data frame called myDF. This is done using the read CSV function, which reads the CSV file and loads it as a data frame. Next, I display the first 3 rows. This allows us to quickly check the data to understand its structure and the type of information it holds. This displays the first 3 rows, showing us how the data looks. Then I temporarily deleted the model column. I didn't use in place true parameter, meaning the column was only removed for the operation and doesn't affect the original data frame permanently. For permanent deletion, I assigned the data frame back to itself after dropping the model column. This ensures that the column is removed permanently. After that, I deleted rows 1, 3 and 5 permanently using the drop function. This ensures that the rows are removed from the data frame without needing to reassign the result. After that, I used head4 to see first 4 rows after the deletion. Next, I calculated the mean of the range column using the mean function. This function calculates the average value of the column. And then to count how many times f appears in the type column, I used value counts. Then I replaced f with aa permanently using the replace method. I confirmed the change by displaying the first 5 rows of the data frame after the replacement. And then I removed unwanted characters like from the cost column using the replace method. This step cleans the column for further analysis. The data type of the cost column became object after removing the characters because the values are still string at this point. And then after cleaning the cost column, I converted it to an integer data type using as type. This allows for numerical calculation on the column. The output is the cost column converted to integer values. I calculated the average of the cost across all rows, and the second result group by continent and calculates the average cost per continent. And then I use group by to group the data by continent and calculate the mean, max and standard deviation of the cost column in one comment. This shows the statistical summary of cost grouped by continent. Similarly, I calculated the mean, max and standard deviation for all numerical columns grouped by continent. This provides a summary for all numerical columns such as cost and range grouped by continent. Next, I visualized the mean of all numerical columns grouped by continent using a bar chart. This helps us to understand the distribution of the mean values across different continents. And then I use value counts to count how many times each continent appears in the continent column. The output shows how many occurrences there are for each continent. Next, I calculated the percentage of each continent by using value counts. And then I use unique to find all the unique values in the continent column, and non-unique to find the number of unique continents. Next, I applied value counts to cost column and describe the results in the following comment. The output shows how many times each cost value appears in the data sets. And then I created a histogram for the cost column to visualize its distribution using hist. The histogram shows how the value of costs are distributed. For more accuracy in the histogram, I increased the number of bins to 50. This gives a more detailed visualization of the cost distribution. You can see in there. And then I checked for missing values in the zip code and type columns. The output shows how many missing values are in each of these columns. A new column named text has been added to data frame. The values in this column are calculated as 10% of the corresponding values in the cost column. The text column contains values as shown in the first few rows of the updated data frame. The head5 method confirms the successful addition of the new column with correct calculated values for the first 5 rows. I sorted the data frame by the range column in a descending order using the sort values function. This sorts the data with the highest cost values at the top. And then filters the data frame to find rows where the cost columns has values greater than 500. For this part, adds a new column, discounted cost, which is calculated as 90% of the value in the cost column. This is done by multiplying the cost column by 0.9. The resulting data frame now includes a new column, discounted cost. And then I filtered the value column. This comment extracts all value entries where the type is AAA. This is useful for identifying and analyzing data. So many outputs. For this part, involves replacing all missing value none in the zip code column with 0 using the fill null 0. We can see there is no. For using the rename, changes applying the data frame. For this part, calculates the correlation between numerical columns in the data frame using the select types. Select only numerical columns. Then the core method is used to compute the pairwise correlation between these numerical columns. Output meaning 1 indicates a perfect positive correlation, -1 indicates a perfect negative correlation, and 0 indicates no linear correlation. And then the data frame might defeat to a new CSV file name Assignment4 updated CSV. The CSV method is used for the purpose with index false parameter to ensure that the data frame's index is not included in the saved CSV file. We can see the output. In the last part, I made groups the data by the continent column and calculated the average mean of the cost and range columns for each continent. Each continent shows average cost and range. We can see both CSV files in there. And that's what I made for assignment 4. Thank you for watching.